Okay, I welcome you once again, ladies and gentlemen, to our next video, having looked at the introduction of integrals of exponential functions in our previous video. Now, we are also looking at the other form of it, where we have an integral of the form a power x with respect to x. So we are going to be learning how to integrate functions of this kind. In the previous video, remember, we had e power a given function. But this time round, it's a constant term. The a you see here is actually a constant term. It can be 2, it can be 3, it can be any other constant. So what do? Do we handle the integrals of this kind the way we handle the ones of exponential f of x, e power f of x? Not really. So follow me carefully here. But before we get started, like I've already said, remember we offer the one-on-one online tutoring services, and it is at a very affordable price. We do it from whatever country you are, from wherever you are, and we offer it our best. Please contact me from wherever you are. You can visit my website, peterekaja.com. And in case you want to contact me directly, you can use plus 256 705110799, or you can say plus 256 784 792 369. Let's get back now to normal business here. First of all, this video will benefit learners who are at advanced level, those who are pursuing maths as part of their combination in advanced level, and we are doing further integration. Now, to integrate an integral, to integrate a function of this form, a power x, what do we basically do? I'm going to give you a step-by-step approach so that we come up with a general expression for this integral. The very first option is I would decide to simply let, for example, u to be the whole of my function a power x. The next step is I can introduce a natural log on both sides so that I have ln u is equals to ln of a power x. Definitely this x will be transformed to this position. Therefore, we have ln u is equals to x ln of a. Now, should you differentiate both sides with respect to x? Definitely here, if you differentiate ln u with respect to x, you will get 1 over u du dx. It will be 1 over u du dx, and this will definitely be differentiating x ln a. Ln a is a constant, so you only differentiate x, maintain your constant. X differentiated gives you 1. That means this is ln a. That is ln a. We are going to make the x the subject. Make the x the subject. Dx will definitely become our du out of u, but ln of a. And then when we come and do the integration, I will say integral of a power x with respect to x is definitely going to be, we called the whole of this, you remember. The x became the u out of u, ln of a. That means at the end of the day, u will cancel out. 1 over ln a will come out of the integral sign because it is a constant. Then you're integrating 1 with respect to u. So it means we shall now have 1 over ln a. And then when you integrate 1 with respect to u, you get u plus a constant. But what is u? Remember, we had said u was a power x. That means you shall have 1 over ln of a, then a power what? A power x. I can just write it up here. Can call it a power x, and then plus a what? Plus a constant of integration. So the integral of a power x with respect to x is definitely going to be a power x divided by ln a plus our constant of integration. What does this mean? This definitely means that if I had integral of exponential, I beg your pardon, if I had integral of 2 power x, if I have an integral of 2 power x with respect to x, I make a comparison. In this case, our a is 2. So I come to this general formula. Wherever there is a, I put a 2, and therefore the answer would be 2 power x but divided by ln of 2 plus a constant. That means if I have another example like integral of 3 power x dx, it would definitely be 3 power x but divided by ln of 3 plus a constant. So with this, it is a basic introduction that I can give, and now I'm going to take you through some examples that require this kind of knowledge. Okay, so let's begin with integral of 3 power 2x with respect to x. If you made such a question, the best option or the easiest option would be beginning by letting u to be the whole of 3 power 2x. To differentiate it, you first introduce a natural log on both sides. So I have 3 power 2x also, but we have a natural log before that. So differentiating this, we get 1 over u du dx. Remember, we are differentiating with respect to x, and then automatically remember this was already 2x ln 3, which now we are supposed to differentiate. So when you differentiate it, you get 2 ln 3. How does that come about? The 2 ln 3 is a constant, so you differentiate x with respect to x, which is 1. So 1 by 2 ln 3, you get 2 ln 3. Make dx the subject. Dx will definitely be du out of. This would now be 2. I can attach it to u, then ln 3. And then when you come back and make a substitution, integral of 3 power 2x with respect to x would be integral of u. But where there is the x, I say du out of 2u ln of 3. What do you realize? The u would cancel. So I remain with 1 over 2 ln 3, which is a constant, integral of 1 with respect to u. So at the end of the day, the answer would be 1 over 2 ln 3. When you integrate 1 with respect to u, you get u plus a constant. That means when you now substitute for u in terms of x, our integral that we are looking for of 3 power 2x with respect to x would be u, but u is 3 power 2x. All this divided by 2 ln of 3 and then plus our constant of integration. As simple as this. As simple as this. So let's go quickly to question 2. Okay, so let's look at this. We are finding integral of 2 power tan x sec x squared with respect to x. Now, in this case, it is still a choice that you take that will help you. If you take a wrong choice, you might find difficulties. But I'm going to maintain that actually still the best option would be we let the whole of 2 power tan x to be our u. Remember, it's just a choice to use u, but you can use any other variable. So if I let u to be 2 power tan of x, definitely I first introduce a ln on both sides, or a natural log. So ln of u is equals to ln of 2 power tan x. If you now follow the rules of logarithms, this transforms to tan x, then ln of 2. Tan x ln of 2. Now, when you differentiate this function, you will definitely get 1 over u du dx, giving us, now on the right hand side, ln 2 is a constant, so maintain it. Differentiate tan x, definitely you get sec squared of x. Make dx the subject. Dx would now be du out of, I have a u here, so I will maintain it there. There is ln 2, there is sec squared of x. Go back and do the substitution. So I would now say integral of 2 power tan x sec squared x dx is equals to integral 2 power tan x, we call it u. Now sec squared, I can first maintain it, but it's going to cancel out because when I substitute the x, which is the u, out of u ln 2 sec squared of x, the sec squared x will definitely cancel. U will also cancel. That means we remain with 1 over ln 2 integral of 1 with respect to u. And that means we shall have 1 over ln 2, but u plus a constant. In conclusion, integral of 2 power tan x sec squared x dx would now be u, but remember our u was 2 power tan x divided by ln of 2 plus our constant of integration. As simple as that. Okay, so we have question 3 now. Let's look at question 3. It is integral of x 3x power, 3 power x squared with respect to x. The best choice still, I will insist, the best choice still would be you deciding to let u to be 3 power x squared. Introduce a ln on both sides. You have ln u. That means it is equals to ln 3 power x squared. Using the rules of logarithms, this would be x squared ln 3. And therefore, from this point, we can now say we differentiate with respect to x. This would be 1 over u, but du dx. On the right-hand side, you have ln 3, which is a constant, so you only differentiate x squared, which is going to be 2x. So it would be 2x ln of 3. Make dx the subject. Making dx the subject means we shall have the u divided by. I already have a u here, but we have a 2 coming up. We have a 2 coming up. We have x also there. Then we have a ln of 3. Go do the substitution. So we now say integral of x 3 power x squared with the respect x is now going to be integral of x 3 power x squared. We already called it u. Then dx became what? Dx became du out of 2u. This is x ln of 3. What do you realize? The u will cancel, x will cancel. So it means the constant we can pull out is going to be 1 over 2 ln 3, and then we'll be integrating 1 with respect to u. And this will be 1 over 2 ln 3 u plus a constant. But remember what u is? U was 3 power x squared. So we make a clear conclusion that the integral of x 3 power x squared with respect to x is equals to 1 over 2 ln 3. Now we have a u there, but our u is 3 power x squared. So I can actually write it as, can now write this as 3 power x squared, 3 power x squared divided by 2 ln 3 and plus our constant of what? Of integration. So this is basically how we handle integrals of this form, and I urge you to do more practice to get perfect, because with integration, practice makes perfect. Otherwise, with these 3 comprehensive examples, I really believe I can now give a short exercise again for you to try out. And in case you get a challenge, we now know how to reach me easily. Okay, that is our short exercise. You will try out these questions. Please make sure you try out, and then you reach out other sources that can give you related questions, practice, and become perfect. With this, I think I just need to remind you that if you've not subscribed to my channel, please do, and then turn on the notification button so that you're always notified when I upload new videos. The other thing is that don't forget that in case you need that direct interaction, one-on-one tutoring services, we still offer them in full swing and at an affordable price. Thank you so much. Bye bye.